A warm welcome, ladies and gentlemen. Welcome to the group exhibit Hydrogen Fuel Cells Europe here at Hanover Fairground in 2023. We are here at the Technical Forum. My name is Mona and I'll be your moderator for today. Yes, we are discussing the technology behind hydrogen and fuel cell applications. We are going a little bit more into details. And also you are allowed to ask questions. Actually, I'm highly inviting you to ask questions because only if you ask questions, you can get smarter. So our upcoming topic will be solid oxide fuel cells for the power supply of off-grid technical infrastructures in every corner of the world. Speaking of every corner of the world, I'm also welcoming all our online guests. We are live streaming from the fair, so moin, konnichiwa, ciao to everyone who is watching us from abroad and cannot be here at this time. We'll have the Managing Director of Sunfire Fuel Cells, Mr. Andreas Frömmel. A very warm welcome.
Thank you. And nice that you're all here. I want to talk with you about this little box, which is a fuel cell power generator. And the power generator is running on propane, natural gas as well, propane, or even on ammonia. Ammonia is the best logistic fuel if you want to carry green hydrogen. And the benefit and advantage of this power generator is that the power generator is really reliable over a long duration. We want to use this power generator at locations where you don't have regular access. For instance, during the winter time, in remote areas, you can't access the site. And then this power generator is the tool of choice to provide power to certain applications. I will come to that in a minute much more in detail. What you can see here on the right-hand side are some features of the power generator. So we can operate in really high altitudes, harsh conditions, in the cold. We can, of course, support that with PV in a hybrid system to take as much as possible renewable energy from the sun. Yeah, and then, of course, which is also helpful, that we can, I would say, survive the time between access to the site could be up to a duration of 10,000 hours, where we don't have the need to come to the site for maintenance reasons and so on. So as you already have heard, we want to provide for critical technical infrastructure the primary power. It's not a backup system, it's the primary power. And every corner of the world means really in harsh conditions. What are the segments? On the left-hand side, you see a gas station. So pipelines, gas pipelines, you need to have SCADA information about the gas flow. We can take the natural gas directly out of the pipeline and can provide the power for such measurements, as well as for valves at the station along the pipeline, regardless whether this is in Alaska or in Malaysia in the jungle. Then, next segment is, of course, then not running on natural gas. In that case, we will run on the propane. It's simple propane you know from barbecue. You can buy in every fuel station, of course, but also a construction market. And here you can see the security equipment. For instance, surveillance, speed control outside at the highway, or rail crossing where you don't have power available, but you have the need to protect and have the need to have signals running there. Then you can take our fuel cell. In that case, you see integration method of a trailer. We are talking about We are talking about this here with the wheels. You can simply carry that with a car. And on the roof, you have PV for a hybrid system. And this is more or less a socket in the green field. You have 230 watt available AC, and you can supply that to application. And the third one is telecommunication, private LTE. In that case, it's a mountaintop installation in Alaska, providing the backbone of the internet towards the northern regions in Alaska for a leading telecommunication provider. And you don't have access to the site during the winter time. And if you want to go up there, only via heli, and it takes 2 days to reach the site. And maybe some of you know the picture on the right-hand side. This is the base camp of the Mount Everest. We supplied there the power to a medical sauna, and we simply bought the bottles in Kathmandu on the market. So you can take normal logistic fuel for those applications. How could we do that? You see on the left side, we have several sources. Could come from bottles, simply propane bottles. Could come from the pipeline, natural gas, or from a tank, if you want to have more volume available for a longer duration without any maintenance access. And then we have the fuel cell. The fuel cell is always combined with a battery, and the fuel cell works as a kind of range extender for the battery. The battery delivers the power to the certain application, also the peak load, so the battery would follow the load, and the fuel cell is operating in a full automated method. What does it mean? The fuel cell is looking into the battery, checking the voltage of the battery, and if we are below a certain level, the fuel cell kicks in, started of operation, and recharge the battery. And then the fuel cell could also work in a part load if here is not so much consumption, or will simply shut off if we have in a hybrid system enough power coming from the PV module. So no need to operate that from remote. It's possible. We are monitoring every station, every fuel cell outside globally, but the fuel cell itself on site is in a fully automated operating mode. And that's it. Quite easy. So you see also here the connection. You can simply put that on site, connect that, and then the unit could run. And to give you some meat to the bones, I want to show you some application as an example, because we are selling this small box there. You can, by the way, see that also in reality at the booth B05. It's in this direction. And here you see the combination with the batteries, desulfurization cartridge. It's an additional one to longer the time between maintenance, up to 10,000 hours, as I said. And then the fuel cell, and if you look in detail, you will see it's an isolated cabinet. And then you see also here the temperature, minus 40 degrees C, and that's the reason why we have here, in that case, together with our Canadian partner, Ansol, an isolated cabinet to be able to provide power really at deep temperatures. This is more for our region, our power boxes. So we have two options. We can combine that with the PV. You see also remote control units. You see the charging units, and you see these 3 bottles in that case of propane. With these 3 bottles, and if you would try to run that full load, then you could reach, I would say, 3 to 4 weeks. But in a hybrid mode, we are more than, in our regions here, I would say it could go up to 6-8 weeks, in summertime even more. without any change of the bottles. And of course, as an operator, you would get a signal if you have to replace the bottles as long as one is full on board. And by the way, we are enhancing that with 5 bottles. You see a lot of space there, so we can even do more of that. That is the installation at Mountaintop in Alaska. It's a radio wave station. This again, you can see here the power box. Also, we taking PV as much as possible. And of course, it really fits great to the Himalaya mountains because it's clean. It's no noisy, no diesel is running. It's the best solution for such installations. Here you can see an example, the compartment at the top left with 3 units in parallel. With a single unit, you have 350 watt constant power, but as you remember, we are taking the peak power out of the batteries, so we could go with 1 unit. I would say it depends, of course, on the size of the batteries, up to 1.5 kilowatt peak power. And with 3 units, of course, you could go up to 5-7 kilowatt peak consumption. And then you have more than 1 kilowatt for recharging. We are also using these boxes for the wind industry. During the construction time, the turbines are not connected to the grid, but of course they are there and they need to be protected, or better to say, the airplanes coming or could come there need to be protected, and therefore the aviation lights to run that even in the construction phase. We will provide the power, but of course you could also charge your phones or your laptop because it's simply AC socket in a green field. Here you can see an example using that for railway crossing. If there's no power available or during maintenance of signals for the railway crossings, we provide the power. And this is the view of the stack. In that case, it's a double stack, but we are using a single one in the Sunfire remote I have shown you. And all these parts are purely made in Germany. It's European technique. The stack is produced in Dresden with our mother company, and the development is done in Neubrandenburg. We are a small team. Here you see the founder of the new Day of the former company when we acquired new Day 5 years ago. Then we focused every fuel cell activities in Neubrandenburg, and Matthias Bolze was the founder of the former company, and now he's my colleague for the technical part and development, and I'm responsible for the commercial part. 20 people, very experienced in SOFC fuel cell business, and we are fully focusing on this remote power equipment. And also to show you a look into our manufacturing facility. It's in the north of Berlin, in Brandenburg. And here we have everything there to develop, of course, further development of the units, but also to manufacture such units. And some of you should know Sunfire itself, which is our mother company. We are 100% subsidiary of Sunfire. Sunfire is focusing on electrolyzer business, as you, I'm sure, know. And we are taking the stacks, the same stacks as they are used in SOEC in a reverse mode. And that's enough for the moment to tell you. I'm curious about your questions. Thank you for your attention.
Thank you so much, Mr. Andreas Frömmel. I have to apologize. We cannot do questions from the audience at this time, but I invite everyone to come and visit you at your booth
BO5 in this direction.
BO5, just around the corner. So thank you very much.
Okay, thank you.